Hello and welcome to the NetScaler podcast. My name is Brian Huhn, and I'm joined by my co-host, Jason Poole. In this special Part 2 episode, we will return to our discussion with Anil Shetty and Dorr, two pivotal leaders in the story of NetScaler, both past and present. If you haven't seen Part 1 of this episode, I recommend giving that a listen first. So, without further ado, let's return to our conversation.
And we're lucky to be joined today by two long-time NetScaler servants who've been around for almost from the start. Anil Shetty, who's the VP of Engineering, and Dorr, who's the Director of Software Engineering. I want to steer out of the Citrix environment for a moment and look at the innovation. It's been 2 decades of innovation, some of the first. And I know that we've discussed them. Let's just put them chronological order. It's not really the right thing. But I remember a big drive, and we touched on this earlier, towards 10 gigabit networking. How is NetScaler as a software ADC able to meet these demands? 10 gigs was a lot. You talked about 1 gig line rate, but how did we progress that through to the 10 gig line rate?
So that was part of the transition to N-Core, what ultimately became known as N-Core. And today it's just normal, but there was a window of time, the NetScaler 9.x release series, that is it's almost 15 years old, 10 to 15 years old. We had a 4-year transition where we actually supported both implementations on the same code base. We had what we called classic mode, which was a single uniprocessor, and we had the parallel implementation that's now known as N-Core. And we ran that baseline side by side. And that's also one of the great powers of NetScaler, one of the key elements of our engineering practices that allowed us to survive all this time was having a single unified code base that then could be built and run in different environments and in different ways. So we get tremendous cross leverage from that. And that's actually one of the detriments and one of the problems of our competitors is the fact that they don't actually have a unified implementation base. And so we see, a certain element of consolidation that happened in parallel to what you're talking about. A lot of our competitors died off as a result of .com, and then other competitors fell away from us during this time window, which is roughly about the start of the last decade, 2010. And we incorporated the 10 gig. We had a couple of different vendors there. And the most successful, really one of the best NIC cards in the whole history of NetScaler is the Niantic design, which came from Intel. It's really a high quality design, outstanding of its time. It was, it seems primitive now, but at the time, it was really an outstanding high quality implementation. And we eventually caught up. First, we start out with 10 gig connectivity. We eventually caught up on the performance side. And so you see NetScalers over the past decade going through this evolution where we produce systems that were first could do up to 40 gigs of sustained throughput. And then we had the breakthrough that took us up to 100 gig. And then at the end, also we're riding the industry in terms of crypto acceleration hardware. That's the one area of our system where we've always consistently used semiconductor acceleration. And the performance goes from 40 to around 100. And then we're producing systems with 200. And the systems we have today we have a top-end system with a license of 250 gig of sustained throughput, all done in software, competing against other systems where their management plane is software, as is ours, but their data plane's in hardware, as ours is in software. And when you compare a system with a hardware implementation versus our design, my way to summarize the benchmarking of our competitors is that they will be always faster. They will always be faster at the packets you don't care about. That's what you get from a hardware data plane. Whereas we have high performance and we continue to evolve, we continue to innovate, we continue to optimize, and we continue to be opportunistic to find ourselves close to some customer use case and then be able to adapt quickly because of our software implementation. It's fundamental to our survival, always has been.
And interestingly, this is a decision we literally took like 24 years ago.
Yes.
Right, to bet on software, right? Focus on commodity hardware and take advantage of converged infrastructure, right? So wherever we can. And that's the design philosophy we carried forward from when we moved from single core to multi-core, from multi-core nodes to multiple nodes, multiple physical nodes, for less clustering.
I wanted to come to that. So, I mean, the 10 gig piece, the 10 gig connectivity, the 10 gig, the catch up to 10 gig throughput sustained rate using the N-core technology. But did that help you? Clustering's always been a goal. Just plug in another one and it will automatically work. But having worked alongside the product managers and the engineers who've done that, I've learned a bit about it. But how has that been implemented using the NetScaler technology of software, being able to make this cluster, and how far can it go?
I mean, it just was a natural evolution for us, right? Because when if you think about it, we have what is called as the entire NetScaler architecture can be broadly split into management plane and data plane. Right. Data plane is not just a singular entity. You have multiple copies of data plane, what we call as packet engine, that runs in every core, in multiple cores. Right when we moved from single core to multiple core, we adhere to a design philosophy of shared nothing, and wherever you can, you try to offload it on commodity hardware. And Dorr talked about NAND technique, and which provides RSS, which is
RSS?
Yes, receiver side scaling, which allows you to distribute or load balance requests to multiple cores at TCP flow level. Right. Okay. So, but it's really our design philosophy to share nothing between these packet engines and offload serial tasks to commodity off-the-shelf hardware, like I talked about RSS or a crypto offload device, is really what allowed us to scale infinitely across cores. But the same design philosophy extends to multiple nodes as well. If you can run with little coordination on the same device, on the same node across cores, the same architecture should be able to be able to extend it to multiple nodes as well. The only thing should be changed was how these data plane engines talk to each other. Okay. Right, so that was just a natural evolution and extension.
So the 10 gig transition was very fundamental, but over the past decade, we've also transitioned into using 40 gig, 25 gig, 50 gig, 100 gig ports, and from multiple vendors. And one of the things about this, it isn't just having a fast port or a fat port. It's also about being able to support port density and having redundancy through something like a link aggregate with the various technologies that exist there. And before we had the 10 gig, customers used to deploy 4 1 gigs in an aggregate. And those techniques are still being used today because of their favorable properties for redundancy and performance. So you have RSS within the system that handles essentially packet distribution. You have link aggregates that not only give you redundancy, but also give you packet distribution and help you perform more efficiently because of providing balance. And then when you start to get into building up multiple systems, you have different redundancy techniques that customers use. HA is an example, active passive. It's a redundancy technique using 2 systems. Our most common clustering deployment is a 4-node cluster. And that 4-node cluster is just a form of redundancy that allows you to tolerate, system or wire failure or network router failure, whatever may occur in the world of the network, and keep the back-end application being delivered to those customers. And as you see customers build up, and there are deployments active today on the planet where there are literally tens of thousands of NetScaler systems. And when you see those extremely large deployments of that form, typically what those customers have done is they've implemented their own form of redundancy up at the routing layer, and they're doing traffic distribution. And then underneath that, we're performing our own redundancy to maintain overall what some people call good through the deployment. There's performance needs, but there's also ruggedization and reliability, right? So that you wind up with a deployment that is, failures occur, and the industry understands that, and so they use these techniques to maintain the customer experience for the end user.
And connecting this back to how the architectures are there in public cloud today is horizontal scaling, very little sharing between nodes, and that's really the same philosophy and design we applied this really back in early 2000s when we came up with the clustering architecture.
We were cloud ready before the cloud.
So alongside those speed increases, to the 10 gigs, virtualization was also a very hot topic, getting a lot of traction in the late 2000s. Given the fact that we were, software based, how difficult was it for us to make, this transition to that next step?
Well, actually, it was not that difficult at all because it was a decision we made 24 years ago to bet on software. And that was a design philosophy right from day one. And that honestly helped us when a lot of the other competition was going towards ASIC and doing a lot more customization in hardware. We were right from day one introducing all of the features and function capabilities on software, right? So because of that, once the virtualization technology picked up, for us, it was really same code base running it in virtual form factor. So you develop features and functions for one mode of deployment, say hardware, appliance, but essentially the same thing carries over for virtual form factor as well. And the beauty for customer is they don't have to change a thing when it comes to managing, monitoring their ADC instances, be it hardware or virtual, because the same code bits down to every bit that we ship on the wire that runs in both virtual and hardware form factor. And it also helped us come up with our own version of multi-tenant solution. And I'll let Dorr speak more to that.
Yes. So the migration onto hypervisors on-prem was natural. I mean, it was one of those combinations was actually on top of a Citrix product, which is Zen Server. And then we also brought to market this hardware platform, which was essentially a mini cloud, a multi-tenant variant of our same hardware. So for the past over 10 years, we've been bringing out companion systems, a single ADC called the MPX, high performance, single box, and then a SDX variant, which is a multi-tenant system, allowing customers to stage multiple copies of the VPX, or they could choose to run on their own on-prem hardware if they would prefer that. And the same code base running in each of these environments. So we continue to get cross-leverage and cross-validation, sending the same capabilities. And from the customer side, they get the same look and feel. They get the same management paradigm. They get the same redundancy capabilities. We support HA and clustering in all these environments. So the customers experience a unified product, and we experience the benefits of a unified code base.
And I know we talked about consolidation earlier, Dorr, and consolidating features into the one device, that was great. But now consolidating multiple ADCs, I know that there was a lot of customers out there who had some Cisco load balancers, some F5, some Altons, and they just put this all together onto the single SCX box. A very popular device over the years.
So another kind of follow-up on that, a little over 10 years ago, being built a software, plays a huge role in that evolution. And now looking at the modern era, it's defined by microservices and containers. And, being software-based, how have we been able to respond to this? Is the architecture, different? Is it much harder? Or is it still giving us that advantage because of the way that we've been created?
Well, we were able to innovate our way into the container world and leverage that style of packaging in spite of the fact that that is a Linux world and the ultimate code base in our history is all on top of FreeBSD. But FreeBSD and Linux they're both variants of Unix. And we were able to continue to move forward with the unified code base and support new environments, including both the container product CPX and then what you referred to as microservices, where you have a single process providing ADC functionality at the very low end, which is BLX, and taking us into new environments. And then, of course, the other development was the concept of the cloud. So our previously successful on-prem VPX virtual guest product was migrated into different cloud environments. Each of them have their own properties, and there are some technical challenges when it comes to orchestration and migrating into these environments. But once you're in there, what you get is you get the same NetScaler performance, high performance. You get the same look and feel capabilities. You get the same redundancy paradigm, and there's a lot of interest nowadays in what are called hybrid cloud deployments, where you have a combination of different types of implementations, each serving their own purpose across a combination of a cloud and on-prem deployment.
So kind of on that topic of hybrid cloud, something we touched on earlier, I want to, look a little bit deeper into. So whether you're running a physical appliance or you're running a virtual form factor, we talked a little bit about how it's all operationally the same. Can you expand on that a little bit?
Yeah, absolutely. So we clearly, back in the day, we clearly saw that trend. Applications moving from on-prem to public cloud, applications more being virtualized on hypervisors. And then lately we are seeing apps are being modernized from monolith to microservices and hence moving to containers and Kubernetes architecture. Now, with all these trends, what happens is from a operations point of view, you are now having to manage these multiple environments. So if you have a solution that is unique to each form factor, guess what? You're going to end up managing each of these solutions differently. Then how are you going to troubleshoot them? All of those complexities start to arise and the operational costs very quickly add up. With our design philosophy, which is right from day one, we're going to bet on software and we're going to maintain same code base, same architecture, regardless of the environment where it runs on. That has actually paid us in spades for us and for our customers. For us, because the same capability you introduce in hardware, boom, is available in virtual form factor, container form factor. For customers, regardless of where you're running, on-prem or public cloud, whether you're running on hypervisor or Kubernetes, it's the same NetScaler. You look and it looks the same way, you manage it the same way. If you're running into application problems, you're still looking at the same set of counters. Everything looks the same. You don't have to change anything on your tooling side. So with this, you can very quickly reduce or troubleshoot your applications, reduce downtime, where you can very quickly deploy your application. So, the overall speed and velocity of deploying and managing your applications dramatically increases.
And I think also something that we perhaps don't make enough noise about is the fact you've got the same features and functionality everywhere. You maintain this security posture is consistent across all your environments. You're not having to worry about, does the WAF on AWS do this the same way as my F5 on-prem and so on? And not to mention the different tools you need. I think that's really important as well to bring out that consistent security posture overall.
That is correct.
So the in parallel to this modern area that we're discussing, the other thing that our customers are increasingly aware of is the fact that we have a tremendous amount of information in the NetScaler, in the ADC, as to what's happening in the network overall. And the product that we brought to market to leverage this capability is called ADM. And we also gave our customers a unified licensing environment so they can create basically a single purchase and enable capability in these different environments, spread the capability across the deployment as best suits their needs, and also choose to migrate either into the cloud or out of it without having to basically repurchase. But the observability part and the ability to understand and analyze what's happening with their application, the information that's coming out of the NetScalers, if anything, it's too much information, and it requires some capabilities to digest and make actionable. And this is an area of innovation that we're currently working in. But it's become more important to us over the past handful of years.
Okay.
So, Jason, I'm going to go back to your comment on consistent security posture. It is so important. I've been to several customers and where I see they will have a point solution for accessing applications remotely through gateway, authentication of application, maybe another vendor. Once you access the application, you deploy application through another vendor for ADC. Then you secure the application to another point product with say WAF. Now, just imagine in this environment, when you have several point products, you're managing these vendors independently, differently. Just imagine the amount of latency and the zigzagging of the packets that goes through these different point solutions. With NetScaler, I mean, you can have the same ADC that can perform all of these roles. You can choose to have it all in one appliance, one form factor, or you could distribute them based on your needs. So it's really all about choice, but ultimately you are still dealing with the same NetScaler. You're still managing your NetScalers and your applications the same way and monitoring the application same way. And another point that Dorr mentioned is so important which is application delivery management, which is a ADM, which is a single pane of glass that you can use to manage ADC instances, NetScaler instances in different form factors across different environments, cloud, on-prem, orchestration environment, VMware or Kubernetes. ADM presents you that unified view, regardless of where you run your application. And I know that's actually one of our differentiator and strengths.
Consistency, centralization, absolutely crucial to everything that we do. Get it? So I'm going to bring this a little bit to a close. So what's next for NetScaler? Where do you see the industry going? So far, wherever the industry's gone, NetScaler has met it there, waiting for it to catch up, really. So what do you see that where the industry's going and how NetScaler is going to meet those demands in the future?
So
without giving away too much, that's okay.
the area of innovation that's most interesting to me is the fact that now that we have we support two operating systems out of a single code base. There's FreeBSD and there's Linux. And the advantage of the Linux product that we have is there's not as much history, and it's actually horizontally portable. So the idea that I'm most intrigued by is the possibility that we could take our Linux products and port them over to ARM relatively conveniently, because the great era of the Pentium that we've ridden for 25 years has created a market need for low power comparable performance. And the ARM is the one who is the processor that's really meeting that need in the market. And as companies get more concerned about their power bill, we should be seeing more and more adoption. The cloud providers are all walking on that road. And I think that the NetScaler should continue to innovate and use our software-based, the power of our system to go where the market is trending.
And just to add to what Dorr said, from a technology point of view, from the market trend point of view, we're clearly seeing cloud is a preferred destination, but so is on-prem. And people are moving away from on-prem. So pendulum has essentially swung back to somewhere in the middle. Previously, it was all cloud only. A lot of drive moving towards cloud, but now it's really hybrid. Hybrid is really the end destination, right? And it's all about giving customers choice. With different customers are in different leg of the journey. Microservices are here to stay. While the containers, Kubernetes architecture are here to stay. Your cloud is here to stay. But really, it's all about giving this choice to our customers. And that's what we do with all of our technology solutions and with ADM as a common control plane to manage all of these different environments.
So we've been discussing the future a bit, and something we love to do on this show is at the end of every episode, we like to ask our guests to make some type of bold prediction on the future, either in the industry or related to NetScaler or anything at all that you'd like to discuss. Could each of you let us know what your thoughts are for the future and what you're predicting?
So I definitely see a trend where the attacks are on the rise, right? That there's a trend on artificial intelligence and analytics and what the promise that it holds. Uh, and these are all are top of mind for our customers, right? Because with the attacks, they're constantly concerned about how their users are, how to protect their users, how to protect their application. And we would like to play a big role in this space. With Citrix, we have already have a footprint on the client side with virtual apps and desktops. We already have a footprint on the application side in the data center closer to the applications with the NetScaler ADC. So we want to really play a role with end-to-end protection. We want to play a role, and we actually see this as a trend as well, where we want to secure all of the access coming in, access of the applications, and those applications could be SaaS applications or private enterprise applications. We want to protect those. And once you're in the data center or once you're closer to the application, we want to help deliver those applications and protect those applications closer to where they are located. So this is clearly one trend where we are seeing in the industry, which is on the security side. And the other trend, as I said, is on the artificial intelligence side. We are in the middle of every request, every response, both on the client side with the footprint with the virtual apps and desktops and near closer to the servers. So we have visibility into every request and every response. We collect rich set of data. We want to make all of this available to our customers, provide out-of-the-box analytics. Our goal is, even if we can reduce troubleshooting time by, say, 25-30%, that's huge because that's time given back to our customers to do other things. That's time when, customers can go back home and spend time with their family or take the time to do something new. We really want to kind of focus on those areas and make it simpler for our customers.
Thank you. Dorr, do you have a prediction for us?
Well, in the past several years, I've been listening to a lot of external negativity on the ADC market, but the NetScaler has continued to thrive. We have had tremendous customer loyalty. The revival of the NetScaler brand shows that the NetScaler itself is an iconic element of the internet. The fact that a brand can persist even after an attempt was made to transition it to something else and then revive and be natural the whole time just shows how within the industry, our capabilities have always earned the appreciation of our customers and the respect of our competitors. And the transitions that we see over the past several years, the move away from hardware, the move onto the cloud, the move into microservices, all of those transitions will play out according to their own timeline. Each customer has their own specific use case and their own specific technology needs. And the NetScaler baseline in the aggregate supports all those environments and will continue to. And one of our great hallmarks is always been our reliability. For our long-term customers, people routinely talk about systems that were showing uptime of 3, 4, 5 years. The field reliability is always been among the top in the industry. And once customers know and begin to trust the NetScaler, that those journeys will continue into the future. So my bold prediction is that we're not going away.
All right. So let me just try to summarize for the audience today. Thank you for your time.
From humble beginnings, NetScaler made a choice to be a software-first architecture and to process packets in a single pass. And since then, the whole load balancing and ADC industry has kind of moved towards it, with increasing customer demands for granularity and more intelligent traffic management. NetScaler has been able to respond wholeheartedly. These early decisions have really paid off and helped NetScaler maintain its advantage in the industry today in terms of performance, in terms of observability, in terms of security, and also in terms of the flexibility and versatility that it brings. And with that, back to you, Brian.
Great. I want to thank our guests so much for joining us today. And I want to thank all of you for watching. You can find our podcast on Spotify, Apple Podcasts, Google Podcasts, and you can also watch the video version of this interview on YouTube or on the NetScaler community website. And if you're already here, please leave us a comment on what you thought or what you might like to hear next. And also, don't forget to hit that like and subscribe button so you don't miss an episode.